Hi folks, and welcome to another episode of OpenNMS 101. In this lesson, we're going to build upon the work we did in the last module, talking about service assurance. Now, one of the key parts of OpenNMS is the ability to monitor services. Service checks, whatever you want to call it, is a very, very key part of any network management system. And OpenNMS is no different. In that episode, we did a fairly simple monitor based upon SNMP. In this lesson, we're going to do one based upon a more complicated monitor called the page sequence monitor. Now, I'm going to go over this, but I want to show you that we do actually have documentation. So if we actually go to docs.opennms.org, and since I'm running 1901, I'm going to click on this 1901 section for releases, go under the admin guide, and over here in this section, you'll see in section 4, we have service assurance. And here's all the different service monitors that we do out of the box. If you're used to Nagios, we've got an NRP-based monitor. Most of our monitors can take the place of a lot of the Nagios check scripts and other checks that most other products do. Now, we have a very simple monitor. We call it the ICMP monitor. That does Bing. Is the remote system providing the ICMP service. We also have a TCP monitor. Today I want to talk about something called the page sequence monitor. This was invented for a customer of ours who came to us and they wanted a way to accurately monitor a fairly complex web-based application. And so we came up with this thing called the page sequence monitor. Now, what the page sequence monitor does is it does the same kind of check that the HTTP monitor would do, but it also adds the ability to walk a series of pages. That's why it's called the page sequence monitor. We follow a sequence of pages. Each page can be either a get or a put. So you can get a page, you can do a put to say log into a form, and you can work your way through a particular web application. And so that's what we're going to do in this lesson. So as I said, we have this range of monitors, and we're going to use the page sequence monitor. And so for an exercise, we're going to look at the OpenNMS login procedure. So what we're going to do is we're going to create a service that says, can you log into OpenNMS? And I honestly do use this service. We use it to monitor demo.opennms.org, where we run a demo. Every so often, something happens, probably about once a quarter. It gets unresponsive. And it's slow. It does actually come up, but it may take 20 seconds or so to load a page. And so what we do is that we have a criteria where we can actually log in, navigate a few pages, and log out. And if that works and everything works timely, we assume the application is running. And so we're going to create this service, and it's going to be called OpenNMS-login. We're going to add it to the localhost node, the one we've been using throughout all these lessons. And then we're going to see what happens. So let me jump over here to my OpenNMS web console. So again, this is 1901. Everything looks nice and green. So I'm going to go over to configure OpenNMS and manage provisioning requisitions. Now there's a couple of ways I can do this. My rule of thumb is if this service, if whatever I'm trying to monitor only exists on one or a handful of nodes, I don't go through the effort of making a detector. I mean, it's pretty easy to make a detector, but I don't make one because I don't want to have to test that service on potentially tens of thousands of devices when I know it only exists on 3. So if I wanted to, I could just edit this class requisition by clicking on the little pencil icon, edit the localhost node, and down here under the interface section, I could edit that interface, and I could just add the service. I could click Add Service, I could type in OpenNMS-login, save it, rescan, and that service would be automatically associated with the node. But I want to show you a way to do this with a foreign source, with a detector. So I'm going to edit our default foreign source here, and I'm going to add a detector. So I'm going to hit this Add Detector button right there. Now, the detector name is going to become the service name, and it's very important because this is a name that's going to be used throughout the system for this particular service. So I'm going to use capital O, P-E-N, capital N-M-S, dash capital L login. Capitals and lowercase characters matter. So I'm going to call this OpenNMS login. Again, for service names, you can use pretty much whatever you want. don't use spaces. There's a reason which I'll cover in another lesson why you don't want to use spaces. It has to do with filtering. Filters don't like spaces. They use them as their own delimiter. So what we try to do is use dashes, use underscore characters, use camel case, but don't use spaces. And then for the class, I'm going to choose HTTP. I can just type that in here. Notice that I could use HTTPS if this was an HTTP S service. I have not configured SSL for this login yet, so I'm just going to use the HTTP detector. But if you are using HTTPS for your OpenNMS, then you may want to use the HTTPS detector. Now, if I just stopped right here, the OpenNMS login would connect to port 80 and basically match anywhere I have HTTP, which is not what I want. So I need to refine this HTTP detector with some parameters. So I'm going to add a parameter, and the first parameter I'm going to choose is port. So I'm going to use the port because OpenNMS runs on 8980. And now that, in my environment, that would probably be sufficient. I don't have any other applications that are running on port 8980, but excuse me. So I don't have any other things running on port 8980. So I could pretty much be safe here, but there are other applications, I believe, I'm going to sneeze again. I could have another application that was running on port 8980. So I want to refine this a little more. I'm going to add another parameter, and I'm going to choose URL. And the URL I'm going to choose is /OpenNMS. So now what it's going to do is it's going to connect to the IP address. Like right up here, I'm running this on my local network, 172.20.1.137, port 8980 /OpenNMS. So that will actually kind of belt and suspenders. So we'll connect to port 8980 and also look for the OpenNMS URL. So I'm going to go ahead and save that. I'll save my changes to the foreign source. And then I'm ready to synchronize this class requisition. And I'll hit yes for this. It'll go through the scan. So now what it should do is go and find it. So let's go to my info nodes. So as you can see, in the time it took me to do this, it's discovered the OpenNMS login service here. And so as you can see, it's not monitored. Okay, we haven't monitored anything here. So we need to fix that. So we've discovered it. We've associated the OpenNMS login service with this particular interface, and now what we need to do is actually create a monitor for it. Remember, discovery is different than monitoring, because if I connect to port 80 and issue an HTTP GET and I get a 500 error message back, that tells me that there's a web server sitting there, but it's down. From a detection standpoint, I don't care. I've discovered a web server. But from a monitoring solution, that would not be an adequate criteria. I'd have to say that that service is now down because 500 is not acceptable. We need like a 330 or a 400, or not a 400, a 200, 303, something in the valid range of responses. Okay, so how do we create a monitor? I'm going to jump back to the slides here. And here is our XML. Again, monitors are created in the Polar configuration file. And here is our entry for this particular service. So, service name, notice capital OPENMS login. This is important. Oh, sorry. This has got to match whatever we discovered it. If you used lowercase, which is perfectly fine, just make sure that this matches. Interval is 30 seconds. This is again in milliseconds, so 30,000 milliseconds. The default would be 5 minutes. Most people with page sequence monitors actually use a longer period of time, 10 or 15 minutes, because you don't really want to pound your web application too much. Not that one extra user should do so, but in many cases it's just not as necessary to test it as frequently. In this case, I don't want to have to sit around for 5 minutes during this demonstration, during this lesson, and wait. So I always set everything to 30 seconds. User defined equals true. Remember, we don't use that, but I always try to set it there. And status on. If you're working on a fairly large page sequence monitor, and you don't want to enable it by default, you can set status equal to off, go to lunch, come back, play with it, etc. Again, I strongly recommend that you run all of your configuration on a test server, development server. I mean, this is a VM running OpenNMS, so it should be pretty easy. Anyway, so like most monitors, we have these parameters. We've got retries, value of 1. Notice that this is a retry, meaning there will be 2 attempts, the initial try and the second retry. Timeout, sometimes you have to set these longer. In this case, this should be fine. I set it to 5 seconds, but you can set these longer the more page sequences you're doing. Skip this repository. This just stores the latency data, and I'll talk about this in 2 more lessons when we talk about data collection. And then this is what differentiates the page sequence monitor from other devices. It's this page sequence key. And here's our page sequence. So the first thing says, okay, /OpenNMS /index.jsp, port 8980, look for password. So I'm going to go log out of here. And so I'm going to go to, let's go and make sure. So this says I need to go to the IP address /OpenNMS index.jsp. So I'm going to go up here. I'm going to type in index.jsp. So as you can see, this actually redirects to the login page, but that doesn't matter with the page sequence monitor. It'll follow the redirects. And so it's looking for a capital P password. So I've got it right there. There it is there. So this page sequence would pass. Notice this virtual host. A lot of web servers aren't happy if you come to them with just an IP address. As you know, web servers can manage a number of different domains. We have one web server in the office here that manages little vanity domains, a couple of my personal domains, and it's one web server, but there's a ton of domains on them. So we have to pass something to it to tell it what the host is. In this case, we use the node label. It does work in this case, localhost, but of course you'd want your node label to match whatever you were trying to do here. Okay, so now that I get to here, I want to do a post. Notice this second page path says post. Again, we're going to go to this JSpring securities check, port 8980, and we're going to post, and we're going to put in some values. How do I know this? Well, unfortunately, what I have to do is actually have to look at the source. So I'm going to view the page source, set it up so human beings can read it. And if I go and look, here is this form. Again, if you're not familiar with HTML, this will be a little bit difficult, but you can see that this JSpring security check is a form in which we pass some values. We pass the J username here and the J password here. I just happen to know by looking at this what these two are. Again, when you're looking at your application, you'd have to know that as well. You may end up having to talk to your web designer or just look at the source. So if I go to JSpring security check, again, this came from right here, this action, JSpring security check. I'm going to set J underscore username to admin and J underscore password to admin. Now I'm assuming, even though early in this class, I told you not to leave the admin password admin, I assume you've done it. I assume it's still admin because I haven't changed it on mine. And we're going to use that as the check. Again, you would want to use some sort of login that wasn't valuable. In the case of the customer who requested this, they were a healthcare provider, and they were using this to look up patients. So we had a fake doctor who only had access to a few fake patients so that we weren't actually using real HIPAA-compliant data. We just want to use this. So I wouldn't use admin as my test. In the case of our demo server, the username and password we use is demo because that's what people use to access it. So anyway, we're going to log in with admin. So let me go back to my screen here, close out that. Type in admin. Ooh, did I do that right? And I'm not going to remember that. So I'm logged in. So let's go back to my page sequence monitor. So my page sequence monitor is actually going to go to, once this post has been made, it's going to go to the OpenNMS index.jsp page, and it's going to look for capital L log, capital O out. And if you see, you don't see it in the page anywhere, but if I actually look at the source, which is what OpenNMS is doing, it's doing gets and it's looking at the source, I can find capital O log out. So there it is, it's right there. It happens to be in the drop-down box under here. So that's where the log out is. So if it finds log out, it says, oh, I made it to this page. Now what do I want to do? I'm logged in. So in this case, it says go to /OpenNMS/event/index. Let's go OpenNMS/event/index. And I got a page. So that seemed to work. And so what is it going to look for? It's going to look for capital E event, capital Q queries, which is right there. So that passes. So I know I made it to this page, and so on and so forth. I could add a whole bunch of different pages here. I think for the customer we did this for, they had 30 or 40 different pages they used. And then finally, you want to log out. You do not want to use resources if you don't have to. So if I go over here and I'll look at admin log out, you probably can't see this on the screen, but it's /J_spring_security_log out is the URL. So I'm going to actually go to /OpenNMS JSpring security log out. And I'm going to look for this input J username. That happens to be, if you remember from looking at the source, that happens to be part of the login form for OpenNMS. So that's it. We've walked 1, 2, 3, 4, 5 pages. And if we can do this and it completes within 5 seconds, I assume that my service is fine. Now remember, every time we add a service, especially every time we add a new service, we have to set what monitor to use, what class to use. So we're going to embed this in our Polar configuration file, but we're going to make sure we add this monitor service line at the bottom. It says to use the page sequence monitor. Notice we use the HTTP detector, but we're going to use the page sequence monitor because, again, I want to beat this into your head. Detection and monitoring are different. Okay, so rather than have you type all this stuff in, you can actually get it from our training page. This may move, but at the moment right now it's in www.opennms.org/T training. And I'm going to go into here's all the slides and videos for these lessons get put up here. They're not there yet because I haven't finished them because we're in the process. Isn't that kind of meta? Like I can't put them there until I've got them done. So, but the configuration file is. So we're in exercise 9. And what I'm going to do is I'm going to right mouse click on Polar configuration and copy that link. And now when I go back to my command line, so I'm on the OpenNMS server in opt OpenNMS etc. I can do a wget-N, which will replace any existing files, and I'm going to paste in that link. So now I have my Polar configuration file. If we look at it, go down to the bottom. Remember we created our own package in our early, we had our little class package for class. So I'm going to add my OpenNMS login right here. And there's exactly what we had put in there. And then we'll go down at the bottom and make sure the OpenNMS login piece is there. Okay. I'm going to save that, and then I'm going to restart OpenNMS. So system control, restart, excuse me. Yeah, that's it. Does that work? I always forget if it's because system control and service reversed it, but I think that's right. Yeah. Okay, so we'll let that run. If you ever want to see how it's doing, you can do a tail -F on opt OpenNMS logs manager.log, and it should show you as everything gets stopped and restarted. Okay, while that's going on, I want to review what we've done. So, we created our login service detector. And this was where we went to the default foreign source. We added our OpenNMS login, and we used the ACP detector with extra parameters. So you can use this for anything that runs on the web. We just had an issue with our Synology box. Synology happens to run on port 5000, so I could, if I had a Synology service, I could put a Synology service, ACP detector, port 5000. And then I could add URLs and other parameters to make that a little bit more detailed. Again, you want to use as detailed as you have to use and then stop. So again, if I just, in this case, had to put port 8980, there may be other applications running on port 8980, and so I added the URL. Next, we rescanned we synchronized. You could rescan as well, and lo and behold, we got this OpenNMS login service. Notice that it's not monitored because we had not created an actual monitor for it. So we created the monitor. We again matched OpenNMS login here, matched the OpenNMS login under the name. We set some basic retries and timeouts, and then the page sequence, which is the important part. So let's see how that restart's going. I'm not sure. It worked. Let's see. It's one of the things I've never been super happy with. I have not been super happy with. Yeah, it didn't work. So let me go ahead and do it with the command line. OpenNMS bin OpenNMS stop. Ever since System 7 came in, I'm not sure if it's our script or it's what they're doing, but restart. You could do a system control stop OpenNMS, system control start OpenNMS. In my case, I'm just going to sit here and use the regular scripts to do this. So while that's going back. So at this point in time in class, let's say, are there any questions? But again, so while I use up some time, I'm going to talk about this again. Remember, when you're doing detectors, you could have gone directly to this node and added, just typed in opennms.login and assigned this service to the node. You don't need a detector. One of the things I use, one of the things we do in the office is we have a drink machine that we monitor with OpenNMS. It outputs the current inventory state to a web page, and then we use the HTTP. We use an HTTP collector, which I'll talk about in a future lesson. We use the HTTP collector to go out and collect that data. Now, I only know that the drinks service is what I think we call it. The drinks service only exists on that particular device, so I don't necessarily want a detector. So all I did was went into the service, went into the thing, and typed in drinks, and that became my service. I will look for the manager.log. While I'm doing this, again, I'm sitting here thinking maybe I should just edit this down, but I want to show you this is like real life, and when you're working with OpenNMS, it's very real. So I want people to become familiar with the logs. And so what I'm doing now is I'm looking at the manager.log. So all the logs live in OpenNMS logs. And as each of the daemons come up, you'll get a log. Now the first one to come up that takes a while is this event D. So once event D is loaded, so right now event D is being loaded. Once it is loaded and running, what will happen is you'll see a whole bunch of other services zoom by because they're very, very easy to load. And then it'll hang on Jetty server. Now Jetty is what we use for our web server. So it's a Java servlet container. And so we use Jetty for this. And what we will do is, it takes a little while for Jetty to come up. And when it comes up, we'll know that it's time to log back in. As you can see, this is the log up here from the last time I restarted it. So you see invoking status on Jetty server. And then, as you can see, status check complete. And then it should say startup complete. So we will wait for that. Again, not sure why that's taking so long. But anyway, again, when you discover a service, it doesn't necessarily mean you're monitoring it. And not monitored isn't necessarily bad. You can have services associated with OpenNMS, specifically services kind of focused on data collection that aren't monitored. You just don't, there's no need to monitor something you're just doing data collection on. So not monitored isn't bad, but in this case, it's saying not monitored because we never created the monitor, which is why we had to edit that polar configuration file. Now, a lot of stuff in OpenNMS is coming about where you can do a lot of this through the GUI, and we're starting to work for the rest of 2017 to actually make things like this easier. But for the time being, you have to actually edit your services using XML. I know it can be a bit of a pain, but it can be easier than writing a particular script. So, okay, so you can see all this other stuff has started. We got act D, alarm D, event D, and now we're sitting here on Jetty server. So Jetty server looks like it's done. We've got startup complete, which means we should be able to log in. Yeah, that was kind of long. Okay, so I'm going to go over here, click on Horizon. It should let me log in. Again, I'm using my Taurus login because you shouldn't be using admin, but we're going to use it for this particular exercise. Okay, so we have 3 alarms. I'm going to click on these right now. OpenNMS login outage identified. Connection refused, connection refused, connection refused. See these reason codes? Notice it's come back up. So we basically determined, oh, it went down and it went back up. Anyone in the class guess what happened? We were starting up. And it happens that the polar, let's go up here, polar D starts before the Jetty server. So we were already polling this service before it came up. And that's why you'll get an outage. Remember, there's no magic in OpenNMS. It is magical, but there's nothing magic. And so the reason is that I want you to know where all this comes from. So this reason code, connection refused, tells me that, hey, it couldn't connect to it because it wasn't running. And notice very soon after, it came back up, and we got all of this login outages, alarms has been restored. Now, let's break it. So I'm going to go to Configure OpenNMS, Configure Users, Groups, and On-Call Roles, Configure Users, and I'm going to modify the admin user, and I'm going to reset the password. So remember, it's currently admin. I'm going to change it to not admin. I'm actually using not admin, but you could use whatever you want. So now I've saved it to not admin. And now, if I didn't do anything else, nothing would happen because I have to hit finish. If you remember from the earlier lesson, you have to hit finish. Now the admin user cannot log in with admin. So if I go to my front page here, within 30 seconds, we should see the outage. Now notice, the last time we had an outage, there were 3 of them because it was on 127.0.0.1, 172.20.1.137, and the IPv6 address. Because we used a detector, it detected all of the OpenNMS login service on all 3 because you could use all 3 to reach it from the OpenNMS side. Had I just edited the node and actually forced OpenNMS-login to be on a particular interface, it would only be on 1. Again, whether you want them on all or none, I'll leave that up to you, but that's kind of explains why that happened. Now, as you can see, we have 3 alarms again in 39 seconds, so we've got outages. The icon, I happen to put an address in on my node, so it's showing up on the map. So this is Pittsboro, North Carolina, where we are, and that's 220 Chatham Business Drive, where I'm doing this, and so that's why that icon changed color. And so now we can go, if I go to Info Nodes, you will see that the OpenNMS login service is down on all 3 interfaces. Now the reason code is different. It says failed to find log out in page content. So since I can see it failed to find log out, I know that it got to this page, but it didn't get to this page. So what happened was it was able to get to index.jsp, so the login. So that gives me a clue. Hey, maybe the login isn't correct. If it had broken, if it had said failed to find information on the event index, then we would know that it had broken there. So this gives you some kind of clue as to where your problem is. Now, if I click on the service, you'll see that the page sequence for this thing is displayed in there. So you can kind of look. You don't have to go digging into the configuration file, nor do your operators. Your operators can go and kind of figure out, oh, okay, this is where it happens. We do obfuscate anything with a password. And so as you can see, the admin password here has been changed to XXX. So very top secret. Now, before my downtime model kicks in, I want to go and set the admin user back to admin. So I'll configure users, modify the admin user, hit reset password, type in admin, Remember to hit finish. And within 30 seconds, we should see these outages clear. And that's kind of it. So notice that everything's kicking in. We've got nodes with outages here. So we've got an outage there. We've got an overall service availability because we don't have the OpenNMS login service in one of our categories. It hits the default category, which says 3 of those services are down. We've got notices that there's some issues. We've got an icon that's changed color. We've got alarms. So bing, 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 everything's all upset that we've had an outage. Now I refresh, outage is cleared, the alarms have cleared, the notices have cleared, and the node has turned back to green. And so that's it. Now I want to tell you something else about, so let me go back to the slides just for 1 second. So we did that, we restarted OpenNMS. Remember, that didn't work for some reason, so you might want to stop and restart. Remember that we got an outage. It may fail on restart. It depends on how fast your server is. If you have a lot of devices in your database instead of just the one, and you have a very fast system, Jetty might come up before the service is polled. But if the service happens to be polled before the Jetty servers come up, you'll get an outage. Again, we changed the admin password. We got an outage, and the thing was different. So we got outages, we've got alarms, we got notices. Perfect. Now, what I want to talk about, one last thing is, notice that in doing this, you had to kind of know a lot about your web application. We had to dig into the source and look for forms and things like that. We have a better solution. It's called the Selenium monitor. So I don't know if many people have known Selenium. If I click on Selenium here. So seleniumhq.org is the website, and it's a browser test suite. And what we can do is you can actually create, using the Selenium IDE, you can actually go through here, test your web application using Selenium, output that test to OpenNMS, and import it in such a way that OpenNMS can then run the Selenium test. There's a number of caveats considering versions and things like that. It's also not documented. So if I go to the administrator guide and I look, Selenium monitor is not yet documented. I am planning on doing an entire lesson in OpenNMS 102, the next class I do, for the Selenium monitor. But at the moment right now, if you want to play with it, kind of work your way through the wiki, and you can feel free to ask in the discussion groups or on chat.opennms.com in the OpenNMS discussion. But anyway, I hope you found this useful. We're going to try and, in the next lesson, we're going to try and tie a whole bunch of stuff together. But I just wanted to show you in this lesson that we do have monitors that do get more complex, but they're very, very useful. Anyway, thanks again. See you next time.